Bismillahirrahmanirrahim. Assalamualaikum. In this video, we'll discuss about looping. Looping inside the coding. Okay. For looping actually is referred to a process where the instruction or the micro-P keep looping, execute the same instruction more than one. Like this one, micro-P execute first instruction, and then execute this if condition, and then if the condition is not true, micro-P will repeat here. We'll go back and repeat the previous instruction again and again and again and again until the condition is changed to true, and only then micro-P can exit from this looping. Okay, so that's why we call looping, because the process will loop here. Yeah. Okay, so to do the looping, what we need to do is first we do the arithmetic instruction like this one. We subtract R1 with 1, and then we check whether the value for R1 is a 0 or not 0. If the value is not 0, we keep subtract the value inside R1. Let's say we put the initial value for R1 is 100, and then we minus by 1. The new value will be 99. We check, not yet 0, so we go and subtract again, become 98, 97, 96, 95, 4, blah 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 until 0. When the value is 0, and micro-P can exit from this loop. Okay, so we say that micro-P do a delay for 100 times 100 times this number of instruction, meaning that instruction subtract, instruction compare, instruction branch will be loop for 100 times. Okay, micro-P will looping here for 100 times, and all these three instruction will be executed for 100 times. So micro-P wastes its clock cycle for 300 clock cycle, because 100 times execute this one, 100 times execute this one, and another 100 times execute this branch instruction. Okay, so after 100 is finished, micro-P can proceed to execute next instruction. Okay, the second method for looping can write our flowchart like this. Start with an operation, we compare the value, and then the subtraction process we write outside the main instruction. Okay, here is the main program, and here is outside the main program. So this is the coding. We label here as a point A, and for this branch I name this branch as ulang, similar with this one. Okay, no operation, and then we check the value inside R0. If the value is 0, if not 0, and then we begin to subtract until the value is 0. So coding for this one, I start to compare branch, compare here, branch here, and then branch here, branch. For branch, if the condition is not equal, and then we take the branch. If condition is equal, we proceed. But since here we want to write the coding for this ulang here, so we need to skip. We use branch, similar with the previous one when we discuss if then else. If then else, we skip. Okay, we use a branch return. Okay, this one. Okay, branch not equal, we branch to ulang, and then ulang, we write this coding, subtract, and then after subtract, we branch back to the point A. In this case, point A to return to the main program. Like this one, branch to point A. Where is point A? Here. Compare here. Got it's point A. But if the condition is true, micro P will branch, meaning that skip this instruction, go to exit loop. Here is exit loop. So and then proceed to execute next instruction. So this instruction for this flowchart maybe it's confusing for you. So you can modify this flowchart to become like this. Okay. So these two flowchart serve the same purpose. Okay. So we start with no operation. We compare r is equal to 0. If no, like this one, we minus r with 1 and then we repeat. We repeat to r0. But if condition is yes, we skip this one. For coding, now we compare r1 with 0. We branch if equal. In this case, for this one, we branch if not equal. Branch if not equal. But in this case, we branch if equal and then we skip this part. Compare, we branch is equal. We straight away exit loop. Here's the loop. Okay. Branch if the condition is not true, compare. Condition is true, it branch. If condition is not true, it will subtract r1 with 1 and then branch again to ulang, to repeat all this instruction, execute to this instruction. If we take the same example with the previous flowchart, I use value for r1 100. For this case, if we put a value for R1 is 100, meaning that micro P will waste 400 cycle. Why? Each instruction will be executed for 100 times. Like for this one, compare will be executed 100 times, branch 100 times, 100 times, another 100 times. But for this one, micro P will waste 500 times, 500 clock cycles. Sorry, 500 clock cycle if you use the value for R1 is 100, because the number of instruction inside this looping is 5. This one is only 4. 1, 2, 3, 4. For this one, it's 1, 2, 3, 4, 5. Compared to the first one, the value inside the looping is only 3 instruction. So 3 times 100 is 300. This one 500, and this one is 400. So normally, a programmer use a looping technique to generate a delay. So if you can see from this example, micro P has waste 500 clock cycle, meaning that if one clock cycle is equal to 1 microsecond, so micro P already waste 500 microsecond here. If we want to generate a 1 second delay, we can modify the program so that micro P will execute this looping for 1 million time. 1 micro, 1 milli. Okay, 1 million times 1 microsecond is equal to 1 second, right? Okay, so to produce 1 second delay, we need to design a program so that micro P will execute this looping for to waste 1 million clock cycle. By assuming that micro P only take 1 clock cycle to execute one instruction. Okay. So again, remember what we have learned before on our digit subject. The relationship between the clock cycle and then is the crystal. If we use a crystal 1 megahertz, the clock cycle will be F is equal 1 over T. T is for tempoh lah kan. Frequency is equal 1 over tempoh. Okay, that's all. Thank you.